Hello everyone, welcome to the first episode of my series on information on a very cool technology which is called brain machine interface. I am Muhammad Rizwan Jafar and I'll be your guide in this information series. So what actually is this brain machine interface? Have you ever thought how we move our arms or we move our legs or how we speak a word or how we sing a song? Have you ever thought how different organs in our body coordinate with each other? All these questions were in my mind when I started my PhD. So I started researching about this in the published literatures, in the videos available on YouTube, in the books. And what I found was very cool and very interesting. I found out that the all information which flows in our body is in the form of electrical signals. Our different organs communicate with each other through these electrical signals, and this electrical signal has a coded information embedded inside it. Let's say for example I hold a hot cup of tea. So suddenly the sensors present on my skin will sense this information and will pass the message through my nerves in the form of electrical signals, which is having a specified coded information. This information will travel through my nerves, through my spinal cord, and will reach my brain. My brain will process this information, will take an action, and will send back this information following the same route through my spinal cord, through my nerves, to my skin, to my hand, which is an actuator in this case now, and my hand will move away from this hot object. And this was the received information from the brain. So what if we can understand this coded information which is traveling inside our nerves? And what if we can replicate this information artificially? And what if we can provide this artificial information to our organs? How cool it will be. In this way, we can trick our organs to perform tasks. So this technology gave rise to a area of research which is called brain machine interface. And this in this area of research we study how this information is flowing, what is the nature of this information, what is the coded information inside this inside this signal, and how we can make mechanical devices which can use this information to perform tasks. And this is called brain machine interface. So how this actually works? So in our brain there are different neurons. These neurons are small cells. So these neurons communicates with each other actually by the help of this electrical signal. So when one neuron passes the information to the other neuron, it is form of a electrical signal. So this passing of information is called firing of action potential. So when one neuron fires an action potential, the amplitude of the signal is very small. That means the signal is very weak. But when the estimated 20 billion neurons which are present in our brain fires action potential, this can be recorded on the scalp. And this recorded information can be used to operate machines. So by definition now, the brain-machine interface would be predicting the state of cognition of a subject, that means of a patient, and generating a control signal based upon the predicted states. That means if we can control a machine using the signals which are generated in our brain, we this whole technology will be called the brain-machine interface. So where it can be used? This technology can be used to develop artificial prosthetic devices. And what prosthetic devices generally are? They can be artificial arms, mechanical arms. They can be artificial mechanical legs. And they can be other kinds of devices also, but generally researchers in the field of brain machine interface are focusing more on prosthetic devices based upon this artificial arm or artificial legs. So what actually happened? Let's say a person lost his arm in an accident. So his brain is there, the nerves are there, his brain is generating control signals, the nerves are still communicating these electrical signals, but the actuator, the arm which was there, it is not present there. So if we can place a mechanical arm in this in the place of the amputated arm, this mechanical arm can be connected to the nerves by the help of certain techniques which I will discuss in the next episodes. So this mechanical arm now can receive the information from the nerves, and this information is coming from the brain directly. So we can train our brain to operate this mechanical arm artificially. In the same way, artificial legs can be operated. In the same way, other you can make other prosthetic devices also. The second implementation of this technology can be in hospitals. For example, a patient cannot convey a certain information to a doctor. For example, a patient wants to call a doctor. He is alone in his room, and he does not have the sensory organs to speak or to move his arm or legs. So what that kinds of patient can do, you can fix a brain machine interface device to a patient that can raise an alarm when he thinks of calling a doctor. This will be a very cool implementation of this technology. Scientists, researchers are using this technology in the field of video games also. Let's say for example you want to move a character in the video games. So traditionally you have buttons of moving a character in the left or right direction. But what if by thought only you can move a character? You will think to move a character on the left side or on the right side, and the character will move. How cool will that game will be? This will be a hit in the market. You can make other devices also. The limit is your imagination. You can imagine, you can create device different implementation of this technology based on your interest. So anyhow, for the inspiration, more inspiration about this technology, I want you people to search about Neuralink on YouTube. The Elon Musk, you know, Elon Musk have invested heavily in this technology which is called Neuralink, and which will be in the market by year 2021 or something. This will generate more inspiration about pursuing this field. I want you guys right after this video to search about Neuralink on YouTube. So anyhow, in the next episodes, I will be telling more about this Neuralink also, and more about how you can use this technology in your area of research. Let's say you want to pursue this in the field of computer science, or you want to pursue this in the field of mechanical engineering, or in the field of electronics engineering. What areas you can study, what areas you can go to, I will discuss in the coming episodes. So till then, I'll take your leave. We'll meet in the next episode. Bye.